everyone. So today we are going to solve our next problem, which is the Leetcode problem 584. So I'll paste all these links in my LinkedIn post as well, so you can just refer to the problem and solve it. So for this video today, what we'll be needing is we'll be needing a SQL interface, so you can directly do it on the Leetcode UI itself, or you can use any other application to solve it. You just have to create the table and insert the data for the query. And also I'll be needing my Google Colab, which I'm using for Pyspark session. So if you have any other ID installed and set up, then you can use that as well. Okay, so let's get started. So today's problem is so basically the last problem that we solved, I mean the first video that I uploaded was more about introducing the where condition in SQL, right? And similarly converting that into a Pyspark problem. So for those who are new to my channel, let me explain. I make videos on solving a SQL problem and converting that into a Pyspark problem. So the main motive for that is that I find SQL easier, as most people would, because it's a very user-friendly language. And once I can solve a problem into SQL, converting into Pyspark is very easy because it's just minor syntax changes, otherwise the logic is the same. So when we go to harder problems, we'll find it more beneficial. So today's problem, it involves, let's see, so we have a customer table, we have columns ID, name and referee ID, and we have the data types as integer, varchar and integer. So the problem statement is that find the names of the customer that are not referred by the customer with ID equal to 2. That means that we have to find the customers that are not referred by the referee ID 2. Okay, so let's see the input table. So we have this data: 1 Will, 2 Jen, 3 Alex, 4 Bill, 5 Zach, 6 Mark. So okay, let me just copy this input data, and first let's see that. Okay, so now what is our problem statement? Our problem statement is that where the customer is not referred by ID 2. So what do we need to do is, basically we need to see where the referee ID is not equal to 2. So this is not equal to 2. This applies, although it's a null, but this applies. And for those who are very beginners to SQL, I would like to say null is just a blank value. Okay, so the output should be will, since we only need to deal with the names. So Will, Jane is going to be there. Okay, then Alex has referee ID 2, so it won't apply. Then Bill will apply because he does not have referee ID 2, it's a null. Okay, and then Zach, because Mark has referee ID 2. So these 4 names should come when we write our query. Okay, so you see this should be the output. So it's going to be a very simple query. So now since we know that there's a where condition, right, so what I'm going to do is that referee ID is not equal to. Okay, so this is a very important syntax in SQL, a very important concept, that is not equal to. This is the how the expression looks like, an exclamation and an equal to. So it's not equal to 2. Again, since we have nulls in the data, we need to specify that as well, that we need to take that where the referee IDs are null. So this again is null, is another expression which is important in SQL. So when we give this condition, that where referee ID is not equal to 2 or referee ID is null, and why we are using or is because we need to find both the conditions apply or not, right? Because if we give a and, then there will be a problem. That it has to if we give a and, then what it has to do is it has to satisfy both the conditions. We do not want that, we want either or. Okay, so if I run this, okay, so you see we are getting the name Will, Jane, Bill and Zach. Okay, and it said that order the result table in any order. I did not apply that, but we can do you also think what we can do. So basically we can order by ID, and let's keep it default ascending itself. Okay, so that's also fine, right? So this is our SQL query for this problem. So now let's just copy it over here and see. Let's just break it step by step. So if we see that we are first selecting the name of the customer, from where, based on the data, this line is the most important one. Okay, so this line, it says that where referee ID is not equal to 2 or where referee ID is null. So this condition, it's applying on the whole data. Okay, it's applying on the whole data, and from there it's selecting everything. Okay, and then from that, okay, let me explain step by step. So it's going to select where referee ID is not equal to 2 or referee ID is null. So it's going to select this 2. Okay, so yeah, so now basically what it is doing is it is first checking for this condition over the whole data. Okay, so first what it will do is it will bring out the records which satisfies this condition, that is referee ID is not equal to 2 or referee ID is null. So this it will bring, and Zach also it will bring because it satisfies the conditions. So this will be the output after the where condition is passed. Now what it is doing is, from this data it is selecting the name. Okay, so it will only give us the name, so Will, Jane, Bill, Zach. Okay, and then it will order by the ID, right? So 1 2 4 5, it in ascending order, since we have given default, we have not given anything, we have, so by default it will take ascending, and this will be my output. So this is the breakdown of this particular query, okay, in SQL. Cool. Now what we'll do is we'll solve this into Pyspark. So I hope this is clear for SQL part. Now let's convert into Pyspark. Okay, so I have the code ready, so I will just explain through it. So as we know that we need to first import the Spark session. So if you need more insights on what a Spark session is, you can refer to the first video that I uploaded. I will paste the link of that as well. But just a gist of it, Spark session is the entry point of writing a Spark code. Okay, so you see the entry point to programming Spark with dataset and data frame API. Again, there are 3 parts in Spark. Okay, so there's an RDD, there's a dataset and data frame. So whenever we are dealing with the dataset and the data frame API, basically data frame is a tabular format thing. Okay, if you have used pandas as well, you will have heard about data frame. So a Spark session can be used to create a data frame and then register the data frame as tables. Okay, and then execute SQL over those tables. We can cache the tables also and read Parquet files. Okay, so for creating the Spark session, this is the basic code which is needed. Spark session builder, and then we need to pass in the app name. So this is basically, you can give any name, ABC, XYZ, DEF, anything, but I have just, the nomenclature should be more so that users can understand, or it should be more user friendly. So I have given like Leetcode 584, the name of the problem, and then you need to also pass this syntax get or create. So when you do that, we are storing it into a variable called Spark. Again, this variable name can be anything. So this will be stored here. Now we are passing the data. We are creating a list with the data that we have from the input data. We are passing a list from that. So you see that over here they were nulls, right? Null. In Pyspark we are passing none. Okay, so there is a different, the things are, the concepts are same for null and none, but there is a difference in the writing, in the syntax thing. So we are passing the data over a list over here, and similarly we have to define the schema as well. Okay, so why do we need to define the schema? The schema needs to be defined because, see, this is just a list, right? And when we want to create a data frame, we need to have the headers on top as well, because data frames are what? Basically those are tables. So tables will have headers as well. So for syncing the data with the headers, we need to pass it into another list which I have defined as schema. It can be any other name as well. So these are the two separate lists which will be, and after this step we'll be merging this headers and the data. So for that, what we need to do is we need to pass this spark.create data frame, this command, and inside it we need to pass the names of the list, that is the data list, and the list which contains the schema, that is the headers. So once we pass this, it creates a table, okay, basically the data frame. It creates that, and we are passing that into a variable called df. It can be any other name as well. Okay, so now we have created the data frame, which is basically, as I said, it's a table, and this will be just syncing the data with the headers with the schema. So once this data frame is created, what I will do is I will just show this data frame so that you will see that what the tabular structure looks like. So what I will do is df.show. So as you know that df.show, it's a syntax to it shows the data basically in the tabular format in the data frame. Okay, so let's see if the table has been created or not. Okay, it takes some time, which is the worst part. Okay, the arrow has come here, so yeah. Okay, so you see that, okay, there's an interesting thing now. So you see that this is the data that has been formed, right? This is the table that has been formed. Now you see it says it's null only. Okay, so it's exactly like the same in the SQL table itself. So when we pass this none over here, so basically it's in the list format, and when it converted into a data frame, when we created the data frame, the values actually transformed into null as it should be in SQL. Okay, so this is a very interesting thing. Now let's get to our condition. So as we did in our SQL, first we did the where condition, because we need to basically shorten our scope of data, right? So this is also somewhat very related to predicate pushdown. I will talk about predicate pushdown in other videos, but the gist of it is that it goes into the data and it scans a part of it. It shortens the data. It's basically, it just brings a subset of the data, and from there it selects whatever is needed. Okay, so the where condition is for that. So similarly, we know that the where condition is basically .filter in Spark. So what we are doing is df.filter, and we are giving the conditions as it is. Now in Spark, you see that in SQL it was is null, right? So similar thing in Spark as well, but without the spaces and the bracket parenthesis. Okay, this is a syntax. So basically the difference between SQL and Spark would be some basic syntax differences. Okay, otherwise condition and logic should be same. And once we have filtered out the subset of data, we are selecting the name. Okay, so this is exactly what we did in SQL. We are breaking into part by part, and then what we will do is we will just show the resultant data. Yep, so you see the name is Will, Jane, Bill and Zach. Okay, so this is how we can convert the SQL, any Pyspark problem, any problem statement you get. First you write a SQL code, it's very easy to write, and then you convert into a Pyspark problem. So this is day 2 of converting SQL into Pyspark. I hope you like the video, and please go through the other videos as well, and please let me know in the comments that how you are finding the videos, if you find it helpful, or any feedback is appreciated. Also please like, subscribe and share with the connections with your friends who need it. So see you in the next video. Bye bye.